Okay, so in this lesson, let's just try to answer this question. In generics, covariance is allowed or not allowed? So if you are following Java, you should be knowing about the inheritance concept. And you know about covariance. If not, I'm going to give you a recap in 1 minute. That's fine. But the question is here, do we have covariance supported in generics? And trust me, guys, this is one of the most important thing that you have to understand before proceeding and approaching generics, because this is going to help you to understand how it works. Well, so let's just try to find out the answer for the question. But before that, I have over here a test class. Let's have a main method, and actually, I want to create few classes here. Okay, just to give you a kind of sample. I'm going to create a class called animal, and I want to create another class called let's say cat that extends animal. So cat is an animal. Okay, and I'll create another class called dog, and dog extends animal. Okay, so there are three classes, right? So what I can understand is animal is the superclass, and cat is a subclass of animal. Dog is also a subclass of animal. Okay. So so basically, if I can annotate my screen a little bit, just understand this is very important. This will help you to understand the concept clearly. Just put this in mind. You have a animal class, and then you have a class called cat. You have a class called dog, and both extends animal. This also extends animal. This also extends animal, right? Now I have a question, right? Can I write animal? Okay, animal is equal to new cat. Can we write this? Simple Java? Of course, yes. Because cat is a subtype, animal is a supertype. So I can put the subtype object inside the supertype reference. So we're going up in the inheritance tree. That's what is called upcasting. I can right now simply write animal is equal to new cat. And in the same way, I can also write animal is equal to new dog. That's also fine. Now I have this question. Let's say I have a class here called box. Okay. And this box is a generic class. Okay. So it's a generic type parameter that I'm passing in over here. Now, simple box example that I have taken this example already. Now let's say inside this box, I want to define T as a type. So I'm going to say private T as a type, and let's say value. And I'm going to create the getter and setter for this value. Okay. Okay, now we have a generic type here called box. Now tell me if I can do this. I'll come to my test class. So I want to put something inside this box. Let's say box. Okay. Let's say I want to put integer here. So box integer. Let's say integer box is equal to new box. And I'm going to define my generic type over here. If I don't define anything, automatically the compiler understand it will be box of integer. It will be infer to the integer type. But also I can put it over here, let's say integer. So this makes sense. That's absolutely valid. Okay. Like that, can I say box of animal? Let's say inside this box, I want to put an animal. So I can say animal box of animal. That's also fine. Okay. So that means inside this animal box, I can set a value, and I can put a new animal, like new animal object over here, which is fine. And I understand that as animal is the super type. The animal has also 2 child classes. I can just put new cat here. That's also fine. And if I want to put here new dog, that's also fine. I want to put any value of animal into this value that it is holding. Now, I want to understand this. Can I say box of animal is equal to new box of cat? Is it valid? It's not valid. So the covariance concept is not working in Java generics. Understand this, box of animal. So this is the base type. This is the generic type. And here what I'm trying to do, here while I'm instantiating, this is the declaration part. This is the instantiation part of my generics. Now in the generic declaration, I'm just saying box of animal. And while I'm instantiating my generic type, I'm putting it over here, box of cat. And it's giving me an error over here and it's saying type mismatch. So what we understand is here, we can't, even if we can do animal is equal to new cat, that's fine with plain raw Java covariance concept here, but the same is not possible with generics. So why this is even not working? What is the reason for that? Let's just test something else. Let's just say, list of integer. Okay, let's say integer list is equal to new array list. Okay, and here I want to specify new array list of integer. Is it going to be fine? Absolutely, because here the generic type is constant here. But what I'm changing here, the subtype. The list is the super type, array list is the subtype. So absolutely, this is the best practice I can do it. But can I say a list of integer is equal to array list of, let's say, the integer subtype. Let's say, what is the super type of integer? Let's say integer class, if I'll go, that extends numbers. So number is the super type here. If I'm going to do control T here, there are a lot of things which basically extending number like short, long, float, a double, big decimal, okay, and even integer. Okay, so what I'm going to do, let's just test this out. If I'm going to put here list of number, integer list is equal to new list of a new array list of integer. That's not going to work because this thing the generic doesn't support, because this is the generic type and this is the subclass of that generic type. It is not allowed, but I can absolutely write number. I can take a number. Okay, let's say I'm going to define a number here, and I can say number is equal to new integer of something. That's absolutely fine. Okay, or I can just put this into one line. That is also fine. So now why this thing is not allowed? Let's just try to find out the answer for this. List of animal is equal to new array list of cat. Why this is not allowed in generics? Why covariance is not allowed? Let's just try to understand that right now. Here is the thing that you have to understand regarding covariance concept in Java. Well, whenever I write something like this, animal is equal to new animal. And if I'm going to assign this animal to a new cat object, can I do that? Absolutely, because cat is a subclass of animal. Can I write new dog here? Absolutely. Dog is a subtype of animal. But as I said, this process, what we call upcasting in Java, is upcasting because here I'm assigning a dog object to a animal reference, which is a super subclass of the dog, and this assignment is possible because of some implicit casting which is happening by the compiler. That means the compiler implicitly casting this dog object to animal and then assigning it to over here. So this is what we call upcasting. Or you can do something like this. As I said, you can do something like this directly. This is also an example of upcasting in Java. But when we say covariance, this is not exactly what we mean by covariance. Covariance and upcasting concepts are related, but covariance and upcasting are not the same concept. The upcasting is basically related to, as I said, assigning a subclass object to a superclass type. Whereas covariance is basically need to deal with the arrays or generic type in Java. For an example, if I'm going to do bucks is a generic type. So bucks is my base type, and here I have to pass the generic type. So the generic type is going to be, let's say, animal. Here, if I'm going to do new bucks of, and here while instantiating the box object, let's say I'm passing dog. Now, this is what I mean by covariance. This is the generic type, this is the generic type, this is the base type, and this is the base type. If inside the generic type parameter, if I might have put animal, and here if I might have put dog, then I might say in Java, generic type can be covariant. But directly, the covariance in generics cannot be achieved. And this is an example of that. One thing I want to highlight here, the covariance type here related to the generic concept. For example, is it possible? Yes, because this is the base type, this is the base type. Well, inside the base type, if this is super type, I'm allowed to write the subtype over here. That is absolutely fine for the base type. But for the generic type, that need to be constant. Even the number is the super type of integer, I cannot just write integer over here. This is not allowed. So that's why I'm saying covariance in Java is not allowed, which is basically related to the generic concept. The covariance is related to the generic concept. But is covariance is not at all possible in Java? We will find out. So let's just come over here and let's just try to understand if the Java generics would have allowed the covariance, then what might be the problem? Why it is always saying the generic type of the left-hand side and the right-hand side should always match. Okay, let's just try to understand this. Let's say I'm gonna specify a array list of integer here. Let's say a list of integers, okay? And let me put it over here like this. And let's just say like this. Another maybe array list I'll define here. Array list of object. Let's say list of objects over here. Okay. So two references I have. One is array list of integer and one is array list of object. Okay. Now, let's say I'm going to do this list of integers. Let me try to instantiate this list of integers. I should say new array list of integer, obviously. If I'll not give anything, anyhow, it will be inferred as the list of integers. Here's the declaration. It is integer. That means even though I'm not specifying anything, this should be type of integer. Okay, that's fair. And just like that, let me also instantiate the list of objects. So list of objects, okay, is equal to new array list of objects, right? So let me also explicitly specify this. Okay, so this makes sense. So here what I'm trying to do, okay, the list of integer I'm instantiating over here. Okay, so I can only add integers over here, list of integers that add. If I'm going to put this add over here, you can see it is only going to allow me to add integers value over here. It's a primitive int value, but anyhow, this is getting auto boxed. This is a auto boxing concept. It is automatically going to be converted to the integer type. Okay, I don't have to do new integer, and I don't have to pass in the number, or I don't have to do integer dot value of then the number to convert it to integer. So if I'm going to put 100 here, anyhow, the auto boxing is going on. Now my question is, can I put a string here? Okay, I can't put a string because this list of integers, which is this, the type here is defined as integer. So types empty. We have already understood the generics concept here. Okay, so what about here? So let's just say list of objects, that we have another objects over here. Can I write add here? So this will allow me to add a list of objects, right? So any type I can add over here, because this list of objects is referring to this and the type is object. So as I said, if it is object here, I can put anything, right? So any class in Java is an object, right? So I can just say Avilas, or I can put 100, or I can put 100.0f, which is the float value, or 100.00, which is a double value. I can pass in a char, that's also fine, because the list of objects is basically, the type here is object, so I can put any type over here. Okay, so now tell me, can I do this? List of objects, okay, is equal to list of integers. Can I do this? So what does this mean? List of objects. So list of objects means this are a list of objects. So what I'm saying is, okay, let's say obj is equal to list of integers, and list of integers, I'm assigning it over here, and this is the value goes over here. So is this possible? I just said you no, because look at the generic type. So this is object here, okay, the generic type, and here I'm passing an integer. So even though integer superclass is object, but in generics, the generic type should be match over here. You cannot put the subtype over here, okay? So we cannot say array list of object, if this is the super type. I cannot say array list of integer extends to array list of object. So this is a different type, this is a different type, so this is not possible. Now let's understand why. Okay, again we are stuck in the same question, why? Okay, let me just tell you now why this is not allowed. Okay, imagine if this would have been allowed. So what would have happened? So let me remove this. Okay, let me remove this. Let me say list of objects here. Okay, and I do not want to create a list of object. I want to put in directly the list of integers over here. Okay, then what will happen over here? What do we mean by this code? So here we are instantiating the list of integers. So somewhere in our Java heap memory, we have a list where we can only put integers. Okay, let's say we can put 100, we can put 200, we can put anything inside this list because the type here is integer. So this list of integer is basically this object because we are instantiating the array list over here. So imagine in your Java heap memory, you have the array list object, okay, which looks something like this, which will contain the integer value. And to make sure only integer type of value is going on over here, that's why we have defined the integer types empty over here. So whenever we'll be adding anything to this list by doing the list of integers that add of 100, list of integers or add of 200, then the compile time safety will be there. So it will make sure we are only putting the integers over there, nothing else. If we're going to put anything else, then there will be a compile time error. You know about this. Now, if you're going to do this, okay, so this is not allowed, first of all, okay, because as I said, array list of integer, list of integers, I cannot assign it to array list of objects. So that's not possible. Why? Imagine if somewhat this would have been supported, because list of objects is the super type, list of integers is the subtype. If it would have been possible, the same reference would have point to this object, right? And in that case, if I can do this, list of integer, okay, which is this reference, I can just do add of 100. This is good. This will go over here and I'll be able to add 100 over here. And if I'm going to do this, the list of objects is also be pointing to the same object, which is list of integer, then this one, okay? So in that case, the list of object is my reference, list of objects dot add, and list of objects is of what type? It is of object type. So I could have put anything over here. I could have put Avilasia, which is a string, or I could have put string like Java here, or Selenium Express over here. So in that case, that string also will be added over here. And we are breaking that compile time safety that the generics is providing us if the covariance would have been allowed over here. That's why array list of object is equal to new array list of integer is not allowed, because we might run into this kind of situation and we ended up putting a lot of irrelevant values like this, where we are needing only the integer value. We might have ended up putting a string over here. This is not the right way to do. So I just want to show it to you. So let me stop annotating. Look at this. If this would have been allowed, using list of integers dot add, you could have been add an integer. You can see it is prompting you to put an integer over here, and like that, list of objects. And we haven't instantiated the list of objects. This is just a declaration. We're assigning to the same integer object. So right over here is this list. It is pointing to the list of integers. This list of objects is pointing to the list of integer, which is this list only, where it is expecting only integer type of value to go. I might have ended up putting an object or anything. See, if I'm putting 100, that's fine. Okay, so I'm not doing any mistake, but there is the absolute probability that developer will be ended up putting a string like this. Okay, and compiler is taking this. This is not giving any warning, because this list of objects, here is the declaration, and we are saying to the compiler, hey, object types are fine. So add anything which is an object, right? So this is why this is not allowed. Okay, got it? Clear? One more example, quick example. Let me give you that. Imagine you have a list of integer is equal to new array list of integer. Can we do this? Absolutely, because there is no problem if you are doing the things with the base type. So this is list, this is array list, that's fine. But this should be integer right over here. Okay. So now the question is, if I can do list of number, okay? So number is the super type of integer. So list of numbers is equal to list of integers. Is it possible? So list of number, I'm assigning that to a list of integers, and list of integers is holding this. So even though this is the super type, I will not be able to assign this to this, right? This is subtype, this is super type. This is not allowed. What would have happened? See, same problem. List of integers dot add, you could have been add an integer. So this integer is entering fine to the list, which is an integer of array list. Now I could have do the same thing, list of numbers dot add. Now the list of numbers, see what it is asking me to add, list of number dot add, it is asking me to add a number. Why? The list of number, the declaration, here I'm saying number. So I could have add any number. I could have add 200, That's also fine, because 200 automatically it is getting like integer dot value of, which will return you an integer object. So I'm saying 100. So this is happening automatically behind the scene. So here I'm passing an integer. That's fine. It is going into this list. That's fine. But what if I would have been added something like 100.202f? Now I'm also able to add a float to this list of numbers, which is assigned to this object, and inside the same list I would have been able to put this float. Where we're expecting integer only, I'm putting a float there. That's why this is not allowed. You can see we're already having a problem. Okay, got it, right? Fixed. Understood? Now let's just see some examples. Okay, I have a question here. So we are talking about covariance concept, and we're understanding that the generic is not supporting covariance. So why Java actually realized this and basically stopped you to do mischievous things like that? The example that I've given in the last video over here. So let me give you some idea like why Java actually stopped you, or Java is not allowing you to do the covariance stuff using generics. Because generics came actually quite late. As I said, it came in 1.5 version, and before that also Java exists. And before generics, basically generics came with collection. So generics introduced with collection, I feel. Now, before that, we were pretty much, working with arrays, right? So if you're going to see the arrays in Java, let's just see how it works. So let's say I want to create a method here, okay? In my test class, I want to create a method which is going to print, let's say, print anything. Okay, so what it is going to print, let me just make it a public static void, and this is the array. Okay, to print anything, it need to take the input, right? So let's just see. If I'm gonna take an input over here, let's say animal array. Okay, that means this method takes the input of animal array. What is animal? I've defined it over here. Animal. And animal extends cat. Animals also extends dog. Okay. So this is going to take an animal array. So my question is, let's say if I have a dog array over here. Let's say dog. And dog array is equal to new dog. How we create a dog object, a dog array object, something like this. And let's say we will put some dog objects over here. So new dog here. So there is one dog object. And let's say new dog over here. So there is another dog object, right? So I have a dog array, right? And like that, let's say this dogs, I'll do one thing. I'll go to this dog class. I'll basically have a variable called private string dog name. Okay, just to have a dog name. And I'm going to have a constructor. So right now I can actually pass in the dog name during the instantiation, right? So right now what I will do, I'll go down, and where I'm defining my dog, I'm going to actually give the dog name. Let's say this dog name is Jackie. And this dog name is Tommy. Okay, something like that. So this is a dog array that I have, which consists of two dog objects, right? So what I want to do over here, I want to pass this dog array to this print anything method. Okay, let's see whether it accepts it. Okay, so can I do print array, print anything, and I'm going to pass in the dog array over here. And look at that, this compiles fine. So to the animal array right now, I'm able to assign a dog array object and it's not complaining. Okay, let's just try to iterate. Okay, so here I'll just write a generic method to iterate any animal. So I'm going to say animal, and I'm going to put over here animal and animal1. Okay, and let's say sys out, and I'm going to print out the animal object. So right over here. Okay, let's just try to run this. Okay, so you can see my couple of dog objects over here. I want to print the content of the dog, not the reference. So what I will do, I'll go to my dog class that I have over here, and right over here I'll just have a toString. Okay, and now let me run this same thing one more time. Right click, run as Java application. Look at that, I have a couple of dog objects, which is Jackie and Tommy. Okay, now let me create a couple of cat objects, and I'll also do some modification in the cat class right over here. I'll just copy the same thing and put it inside my cat. Okay, and over here in the toString, here I can say cat name, and this is a cat object, right? So there you go. This is my cat class, which has a variable called cat name. Right now, let's just try to instantiate a cat array over here. So I can just say cat array, and I'm going to say cat array is equal to new cat, and I'll be passing in a couple of cat array objects. So I'm going to say new cat. Okay, and I'm going to put in the name. Let's say I have one of my cat name Milky, and I have actually another cat, new cat, and her name is Silky, and Milky is the guy, Silky is the girl. So now I can say print anything. Can I pass the cat array over here? And absolutely, that's fair. I can still pass the cat array object over here. And look at that. If I'm going to run this, okay, see, I'm able to iterate the cat. The thing is that the print anything is basically taking an animal array, and it's basically taking in any kind of animal, right? So basically I'm able to do this. Animal is equal to new cat. Okay, and I'm allowed to do this in array, or I can do this. Animal1 is equal to new dog. I'm allowed to do this in Java array. Okay, but what's the problem over here? If you're going to do this kind of thing, okay, that is a very bad thing you can stalk into. I'll tell you how. Let's just come to this example. Okay, don't want you to see anything else. Look at this example. I'll go with this animal example that we have over here, cat. So I can have animal. Okay, let me assign. Okay, here let me not initialize here. I'll just say I'm gonna put 2 things inside the array, so the length will be 2. So here I'm gonna say animal of 0. I'm gonna assign my first cat object over here, new cat, and let's say Milky, and animal 1 is equal to again a new cat, let's say Silky. Okay, both of my cat. So I'm just feeling a little good writing their name. Okay, so I have a couple of animals right now. So it's all working good. If I'm going to compile, no problem, working good. So this, I don't care right now. So let me comment out everything. Okay, so if I'm going to run this, so no compile time error. Okay, so nothing there in the console. Now can I do this? New dog, and let me give a dog name, Jackie. Is it possible? I can see there is no compile time error over here. But here I can see a problem. What is the issue? The issue is, I'm saying here, I'll be using animal which are of type cat. So I'm able to create the cat instance over here and assigning it to animal of 0. So it is taking it, that's fine. But here, whenever I'm assigning it to a dog object, it is still taking it. Okay, if I'm going to run this, I have a problem here. It's giving me an exception called array store exception for the Java 83 line number, which is this. So this is a problematic line. Okay, so here the Java array is basically allowing me covariance. So where animal is the supertype, and into the supertype object, reference, I'm able to assign a subtype object. So it's allowing me covariance, the Java array. But I got stuck into an error called array store exception. Whenever this kind of issue happens, there is no compile time protection here. You can see I do not have any warning or error in the compile time, but Java is allowing me to do this. But when I'm running the program, I'm stuck with this array store exception issue coming for this line. So Java people actually realize that this concept that they have in array is problematic. So in generic, they will not allow you to do that. Okay, they will not allow you to do, let's say, list of animal, and animal is equal to new list or array list of cat. Okay, there will be a type mismatch over here, and you won't be able to do that. Now, if you won't be able to do that, how you will be able to replicate this kind of example? Okay, because here you can see we are able to create generic method by accepting the animal, the super type reference over here, and we're able to pass a dog array over here, a cat array over here to this particular method that we have created over here. Okay, but we found there is a problem with this approach. Okay, if I'm gonna uncomment this, we found there is a problem in this approach. But the problem that we have with this approach is, let's say I'm gonna comment this couple of line. Okay, I'm passing in a dog array over here, and into my print anything method, let's say mistakenly I'm trying to override something here. Let's say animal and animal of 1, and I'm giving a new cat object. This is gonna take this, and no compile time error or warning, but we're gonna be stuck into an exception while we are calling this method right over here. So this is a problematic code. But anyhow, if we don't do this kind of thing, the Java array allows us to take the super type as a parameter and allowing us to do code like this. Okay, so we can pass in a cat array, we can pass in a dog array, everything to this. Now, how can we approach the same thing with the list? Now let's just have an example of that. So my simple question is, can we create a method like this called print array or print anything right over here? Okay, where I want to take a list. Okay, let's say list of animal. Okay, and I'm going to say animal. Okay, and I want to iterate over this, but I want to call this print anything list. Okay, let's say I want to call, let me remove all this, print anything. Now I want to pass in any type of list. Let's say I'm going to create a array list over here. And I'm going to say array list of cat. Okay, and I'm going to say list of cats dot add. I can only be able to add cat. So new cat. Let me add few cats over here. Okay. Now my question is, can I put the list of cats over here? Or can I create a list of dog objects? Okay, something like this. Okay, and can I pass this list of dog to my print anything which tags an array? Let's say list of dogs. Okay, so I just told you that this is not possible. I cannot pass in a new list of cat object. So if I don't write anything, it will be anyhow inferred to array list of cat. So I cannot pass in an array list of cat to print anything, because the print anything basically, one second, print anything. I don't want to use this. Let me remove this completely. That's the array thing. Okay, and let me just get rid of this. And now look at that. So let me hover on this right now. So it cannot accept, because the list of animal is the type test is not applicable for argument list of cat. Okay, so list of animal it is taking, which is not able to accept the list of cat over here if I'm putting it inside this parameter. Like that, the list of dog I cannot pass into this print anything method, which takes a generic type of list of animal. Okay, so what I can do over here? So I can do this over here. So this is not possible in generics. As I said, we can do it because this is type, the covariance type is not allowed in generics. So to fix this, I'm going to give you a temporary fix. So to fix this, what we can do, we can just remove this type over here. So you might think, okay, define T, but if I'm going to define T, there is nothing. T is not defined over here. Okay, so I have to again, define the T types over here. I need to make this method a generic method. But instead of saying T here, I will say to the list that you will be able to accept any type of list. Okay, any unknown type I will allow. Okay, so list of any unknown type. So I'm going to give a wildcard over here. Okay, so here I can see this question mark, what I call a wildcard, and this means list of any unknown type. So that's how we can read it, list of any type, any unknown type. Okay, so whenever you are designing this method right now, let's say you don't have any source code, so you are creating this method, you know, inside this method any type of list could be passed. Okay, so any type of list, a list of anything could be passed over here. So in that case, you can make it list of unknown type, because you don't know, like whenever you will be calling this method, that time you can define the type of the list and can pass in the type. Okay, now if you're going to do this, okay, you can see your methods should compile fine here. If I'm going to do Control S, this compiles fine, this compiles fine. So now the print anything method allows any type of list. Okay, now the thing is that why we're having a problem here, because when I say the list of any unknown type, okay, what this animal could be of any type. It can hold a list of integers, or a list of string, a list of cat, a list of foo, a list of dog, a list of animal, a list of integers. It can hold any type of thing, right? So if it will be any type of thing, we don't know what is the type is. So I cannot say, hey, this animal, I want to extract animal type of object. No, I'm not sure about this. This means anything. Like, I'm going to give you an example here. So when you say list of any unknown type, list of unknown types, that means you'll be able to assign anything over here. Okay, you can able to assign a new array list of integers. Okay, that's fine. Now the list of unknown types, to this I'm assigning a list of integers. To this I'm able to assign a list of cat. That's also fine. No error. I'll be able to assign a list of dog. That's fine. I'll be able to assign a list of string. That's also fine. So I'll be able to assign anything to this type. But whenever you are defining something like this, okay, once the declaration is done, so basically, okay, so you understand this much right now. Here, the compiler will see the declaration part. This is the declaration. This is the object instantiation, the generic type instantiation. You're doing it over here. You're instantiating this generic type to a list of string. Now, whenever you do this, the compiler will see the left-hand side and will say, okay, I don't know what kind of object this list of unknown type will hold. This could be anything that the developer will assign. Okay, so here the developer is assigning string, but it could be absolutely possible that the developer will change this list of unknown types to, let's say, new array list of dog later. You can see like this. Okay, so this one right now, I'm changing it to array list of dog. So this is not complaining because this list of unknown type, this could be of list of any unknown type, list of any type. So if I'm going to say array list of dog also, that's fine. Later in my program, I can change it to list of cat also. That's also fine. This reference will be able to hold that also. So when you define this is your declaration part. Here you are saying that I don't even care what type of list will be assigned to this list of unknown types, but I'll be able to handle any kind of list. But if you're going to see a real-time program and code, you will never see a list is basically have instantiated like this. This list of something is mostly we use in used as a parameter type. Okay, let's say something like this that I've said list of this animal. This means list of anything. So while I'm coding this method, I don't know what type of list I'm going to be getting. So I just made it list of any unknown type. Okay, but right now, the example that I'm giving you is look something like this. This is just to make you understand this can hold any type of list object, right? You understand that? Now I have one more question. So now you answer me this. Let's say I'm gonna cut this. I'm gonna say null here. Let's say I have a list of integers is equal to this. And let's say I'm adding some list of integers that add, and I'm gonna say I'm adding 10 list of integers that add, and I'm adding 200. Let's say I'm adding few things over here. Okay. And then I'm assigning this list of integers to this. Okay. That means right now what I'm saying, now I'm assigning to this list of unknown types to list of integers. So can it take it? Yes, it can take list of integers because it can take list of any type. Okay. Right now, if I'm going to do list of unknown types dot, let's say get, what are you going to get? You can already say this. Whenever you're going to say get, you're going to get an object. You won't be getting the specific type of object because whenever you declare this is the declaration part. Look at this much. Okay. This is the declaration part. Whenever you have declared the list, you haven't defined the type. So the type could be of any list type. So that's why whenever you say get of 0, the compiler says, well, you're going to be getting something, but you will be getting that in form of object because this should be a list of integers or list of string or whatever you are assigning to this. End of the day, they are objects, right? So whenever you do get, in which format you're going to be getting back the variable over here. So if you're going to do assign statement to a new local variable, you're going to be getting an object back. Okay. So this is how the list of unknown type works, right? So now if you're going to do sys out of object, over here you're going to be getting the get of 0, which is 10. So this is very important to know. So whenever you're going to do a get from a list of unknown type, you're going to be getting or retrieving the objects only. And this type of syntax is mostly used for that purpose. Whenever you want to fetch something, whenever you want to retrieve something from some unknown type of list, you can declare something like this, just like over here. Okay, so list of something you have defined over here is animal. So this animal here is giving you an error. Why? Because I'm trying to convert this animal to an animal type. But no, this could be of any type. This could be of integer type, double type. When somebody calls this method, they can pass anything over here, right? So we're not sure what kind of data that you're going to be getting. So the example is over here, right? We can pass in a list of cat. We can pass in a list of dogs to this, right? So we do not know this print anything this is going to hold what kind of list. That means whenever you're going to fetch something from this, if you're going to do animal dot get, see what you will be getting, an object back, right? So what you can do here, instead of writing here animal, you can write object, okay? And then your method should work fine. So if you're gonna, I'll come back to this. So just comment this for a moment. So if you're gonna run this code, okay, this should work, right? You can see print anything takes a list of cat, and print anything is also taking a list of dog, and is also able to iterate this. So whenever you're going to be fetching anything from this list of unknown type, you're going to be getting an object back. Okay. Now this is whenever you are retrieving something, and for retrieving purpose only, this syntax is mostly used, and mostly it is used inside the method parameter only like this. So it is rarely used like this, the example that I have given you over here. This is just for example. Here I'm just saying list of unknown types and assigning the list of integers over here. But I have a question here. Okay, so why generics is used? Generics are used for giving you compile time safety. Okay, so whenever you are defining something like this, list of any type. So what do you mean by that? So still you want to say, I can accept list of any type, any unknown types of object. But that doesn't mean that you can able to add anything to this. For an example, here, list of unknown type, list of unknown types. If I want to take this reference over here, you won't be able to add anything to this list right now. Okay, so this one, if you're going to add over here 100, will be able to add it? No, you won't be able to add it, because during the time of declaration we don't know the type, okay, what this particular reference will be holding in future. Here I'm just giving you an example, but this could be have any other type as well. So whenever I'm going to put 100, the compiler will say, hey, I don't know what type of data this guy has, so I will not allow you to add anything over here. Okay, so do not consider this like an object. Okay, if it would have been object type, it would have been accepted 100. It would have been accepted new cat. Okay, this also would have been accepted, but we will not be able to use the add method from this list of unknown types. So whenever you see this, this is just for retrieving purpose, or you want to do something with the list, but you won't be able to add something to the list, right? So this is invalid. Okay, but can we add a null? Okay, null is not of any type, right? So we can happily add a null to this list of unknown types. So right now, if you can print, okay, list of unknown types here. Now this is going to give you run as Java application. Okay, this is going to give you null over here along with 10 and 200. Okay, but apart from null, you won't be able to add anything. But the good thing is that you can do any kind of other fetch operation right over here. Let's say you will be able to do get happily. That's fine. If you're going to do 0, that is working because you are retrieving something. Okay. If you're going to do list.size, list of unknown types.size, you'll be able to do it because you are just asking, okay, how many elements that you have inside you? Hey, list of unknown types. I know you are containing some types of objects. Okay. That might not be, you might not be know about that whenever the declaration happen, but I just want to know the size. So you can happily get the size over here. Okay. And if you want to print it, you'll be able to print the size of the list, right? But whenever this reference you're using, basically this reference belongs to what type? This list type. If you go to the list class, it's a generic class. If you're going to see any methods which does not involve this E here, the generic type over here inside the parameter, you will be able to use all those kind of methods like size, is empty you can use, contains you can use, iterator you can use, toArray you can use. But look at this, add. Here E is coming. What is E? E is defined as the class label generic type parameter. Okay. The methods which has the class level generic type parameter as an argument right over here, you will not be able to use that. Like add. Okay. Remove you can use because it takes in an object. But look at this add all method. Okay. There is something written over here. I still don't understand what is this question mark extend something, but it's written E here. So inside the add all parameter, it has this E thing over here. So I won't be able to use this method. I won't be use this add all method. I'm going to give you an example, by the way. Okay, let's just check another example. Well, I have removed everything from my main method. So what I'm going to be doing, look at this. I have this box class created. Okay, it's a generic type class, expects a generic type to be given to it during its initialization. So whenever I'll be using the box type class, and then I only can put a string inside this box. So I can just do box of string dot, let's say set value, and let's say it could not be integer, it can be only string over here. Okay. And I can also get the value from the box. They said if I want to do get value, it's automatically return string, as you can see over here. This works is casted to string automatically because I've defined the generic type during the declaration. But let's just see the same example with an unknown type list. Let's say not unknown type list, an unknown type of box. Let's just see this example. It's a box of, and during the declaration of the generic type, I will not be declaring the type of it. I'm going to say, hey, I'm not sure, or I don't care about the type, man. I just want to write the box of any type. Okay. And let's say I will not define it right now, unless I'll define it later. Okay. So in this case, I always can do this box of unknown type that gets something. I want to retrieve something from the box. Once it get its value somewhere during the code, okay, you will be initializing this type. Okay. Once you do that, you can just do get value. But as I said, you haven't defined the type over here. So the Java compiler doesn't know what type of value this box is going to contain. So whenever you're going to do a get value, you can see it's always going to return an object, right? But the interesting thing is, if you're going to do box of unknown type dot set value, which is again the method that we have inside the box class, can we use this method? Look at that set value method is defined where? Inside this box of unknown type. What is this box of unknown type? Did we define the generic type during the declaration? No. If we haven't defined the generic type during the declaration, then this box, this T, we are not defining. If we're not defining the t, we cannot use any type of method that we have inside the box class which takes a t as a parameter, because during the declaration or the instantiation of this box, we haven't defined the t. So if we haven't defined the t, so it will not allow you to use the set value method or any methods this class has which has this t parameter, which has this class level generic type parameter. If you have it inside the method parameter or method argument, you won't be use that particular method. In our case, if you can come to our main method, here the set value method, you won't be able to use, because if you can add a list, if you can add a string to this box type, or you can add a double to the box type. If you can add a double or a string or anything over here, you might be breaking the compile time type safety. How? For an example, imagine you have this box of string and you are setting a value, string value to this. Now this, I'm going to assign to this. Is it possible in the first place? Yes, absolutely. Because box of any unknown type means you can add over here a box of string, or a box of integer, a box of double, a box of foo, a box of bar, anything. But whenever you do that, you can retrieve the data. You can use the get value. It's going to get you the value that you're putting over here. So if the set value method will allow you to add anything over here, where during the declaration only you haven't defined the type of the box, then you might run into the same type safety issue. You might be able to add anything to the list of box of string. You'll be able to add this double value, and whenever you're fetching the value, you might end up with class cast exception. And the main thing, the generic help us, it protect us to put something weird to the object that you are creating, and it just do the type checking. Okay, and if it is allow us to put anything over here to the box of unknown type, then during the compile time, the compiler is not sure what type of value this box of unknown type is holding over here. The compiler cannot look into this and cannot say that, okay, inside this you have this, because this reference can change anytime and you'll be ended up putting some wrong type of value into a particular object. All right, so now let's just go ahead and practice a little bit of this wildcard, and how can we basically deal with the code where a wildcard will be required. Well, we basically understand it is used mostly for retrieving purpose, and we should avoid it where we need to put something into a array list or a collection. Okay, let's just see some example and get ourselves acquainted with this wildcard in generics. Imagine the method I will develop here is, let's say, find common elements. Imagine I'm going to be passing in couple of list here. Okay, let's say list 1 and list 2. Then this find common elements will print the common elements which is present between this couple of lists that I'm providing. Okay, let's say I have a method here called public static void this. Okay, and let's say I want to find the common elements between couple of lists. Let's say list of integer, and this is also list of integer. Let's say I'm going to pass in couple of list of integers to this find common elements method, and its job is to find the common elements that is present between this couple of lists. Let me create couple of array list over here. So there you go. There are couple of array list of integers that I have created, and I have added some elements to this. And you can see this list has 10, 20, 30. This list has 30, 20, 60. That means here 30 and 20 are common in this list. Let's say if I'm gonna use this find common list method over here, and I'm gonna pass in this list of integer 1 comma list of integer 2. Okay, then over here this method will accept that couple of list, and we can simply figure out the result. We can just iterate over a list. So I can just write a for each loop. And obviously, I'm going to be iterating over this list one first. I'm iterating over this list one. It contains the list of integer. It's very specific that we will be getting an integer list whenever somebody is going to call this. And yes, we are passing this integer list to here, which contains a bunch of integer object. So I'm going to do list one, which is this object. And I'm going to be iterating over this, okay, integer object. Then I'm going to do what? I'm going to be checking while iterating the object that I'm fetching from the list, if that present inside this list. So I'm going to take this list2 reference and I'm going to say if list2 contains the integer object. If that's the case, so this is going to get me a boolean. Okay, let's say is contents. Okay, so if this is true, if is contents is true, if I'm going to put it over here, then I can just write sys out and I can pass in I can print the integer object. And that's the implementation for this method. Let's just see whether I'm able to get the correct result. If I'm going to run this, say I'm going to get 20 and 30. Let's say inside this list I have 30, 100 and 60. Let's just see how many common elements that we have over here between these two lists. And here it is only 30, and that makes sense. But my question is, can I use this method right now, find common elements for two different list of strings? Here, let me create two list of string objects. Okay, so here you go. Here you have two list of string object, and here I'm adding a v selenium express to this list, and this is another array list of string where I'm adding selenium express Ramesh to this list. Now my question is, if I'm going to pass in, will this method work? And obviously it will not, because here it is taking a list of integer. So maybe I need to create another method where it will take two list of strings and then I can do the same check. But instead of that, if I am not sure what type of objects I will be getting over here while designing this method, let's say I'm not sure I'm going to get the list of integer or list of string or list of foo or list of bar, then I can just say list of some unknown type, something like this. So a couple of lists I'm defining, but the types are not known. So here only one changes I have to do here. So whenever I know like this list that I'm going to have over here, I do not know the type of it. So the value that I will be, whenever I'll be retrieving the value from the list, it is going to give me the value in object format. As I said, if I'm going to do list1 dot get of 0, if I'll try to find what this get method is going to get me, see, this is an object. So if I'm going to do control1, assign statement to a new local variable, is going to get me an object back, right? So as I said, while reading, this is always going to give me objects back. So this list one here, instead of integer, I'm going to say object, and that's it. Things should work fine. But yeah, one thing I will just do, instead of saying integer object, I will just change this reference. So I'm going to say refactor, rename, and I'm going to say, let's say obj. Just right over here, just to be more specific that this could be any type of object, right? If this is list of integer it is holding, then this object will be of integer type. If it is holding list of string, then this will be of string type. But most important thing is that if you're going to see the method where I'm calling this doesn't give me any error. This method also doesn't give any error. So now here I'm passing in couple of list of integer to this, and this list one is holding a list of integer. This list two is also holding a list of integer, and it's vice versa for the string. And if I'm going to run this, it should work fine here as well. You can see 30 for the integer list is the output. Selenium Express is the output for the string list whenever we're going to be doing this comparison. Okay. But one thing I want to drag your attention to, whenever I have designed this method, you can see that this list, I'm not sure what type of list this is going to be. So this list is going to be some unknown type. So as I said, you won't be able to add something like this list1 dot add, and you won't be able to add anything. You won't be able to add a string over here or an integer over here, because we are not sure what type of list this is going to be in future. Whenever somebody calls this and going to pass the list object, we are not sure what type of that list is. This add method doesn't work over here. But you can see here I'm safely using list2.content. So what is the list2? This list2 is a list of unknown type. But I am able to use contents here, because this contents takes what? If you're going to see the contents of list2, the contents takes an object. So it is not the generic type parameter we have over here. The class label generic type parameter is E. So it is not E, it is object. So any kind of object I can pass in over here. So that can be safely done. So if I'm going to go to this, so I can call the contents over the list2, and that's fine. Okay, that's the rule I've given you. So you can just do, let's say, any list1.get. You can do safely. There won't be any issue. You can do list1.size. There won't be any issue, because you are not modifying the list. But the time you start to modify the list by adding some element to this, then there will be a problem. What you can only do, you can only add null over here. So list1.add, you can add null separately, because this is not any kind of object that you're adding. This is just something like null. Only null you can add if the declaration is like this. Otherwise, you won't be able to modify the list in this kind of example. Hope that makes sense. So mostly, guys, you will be using your wildcard like this inside the method parameter. You will see less code like this. You won't be even see any code like this. This is a valid piece of code. Here you are defining the array list of integer and assigning to this, and this can take any type. So this is allowing, but you won't be seeing code like this. Okay, for the instantiation of the generic part, you will most likely see while developing generic method like this. Okay, so this is the difference between this wildcard, where you should use. And if you have a question like where should I use T and where should I use this question mark, okay, in that case, what you can think like, it will be, as I said, it will be mostly will be used inside the method parameter. You cannot use that. You cannot use that question mark, the wildcard, as the generic type. You cannot do something like this. Okay, this is not allowed. So if you think like you can do something like this, this is not allowed. Why? Imagine you have two parameters. Let's say you have T, you have V. So you can take T over here, you can take V over here. Okay, let's say this is value 1 and this is value. This is absolutely fine. But let's say if you are giving question mark over here, okay, then this will be kind of ambiguous, right? You don't know which question mark belongs to what. Value 1 type is what, is both look similar, right? So this cannot be used in the generic type declaration. You always need to use an alphabet like T or V or something, the way I have told you over there. Okay, and that's the thing. Okay, and I think you understand that pretty well right now. The question mark thing, the wildcard things, why we do need this.
Okay, so far we understand generic in Java does not support covariance. But what about this? Let's say I have a list and I want this list can accept any type of animal. So here I can do something like this. Any unknown type extends animal, any type list is equal to new array list. Okay, and over here I can put an array list of cat. Let's just see whether it is allowing or not. Look at that. Now I just said animal here. I'm allowed to put cat here. I'm allowed to put dog here. I'm allowed to put animal here. But am I allowed to put integer here? No, that's not possible. Now, if this is animal, this need to be the subtype of animal, like dog. So, looks like the covariant in generic is kind of possible if I'm using something called a wildcard along with the extends keyword. But how does these things work? And what exactly mean by this extends, and what exactly mean by this super, and how all these things works, and why I'm getting an warning over here. Oh, this is an error. Why right now suddenly I started getting an error? And what about this keyword called super or extends, and how does all these things works internally? And that's the concept of the covariance in generics, along with the upper bound, lower bound, extends, super, and all that we'll be discussing in the next video. See you there. Till then, make sure you practice everything, and as always, don't forget to like this video and don't forget to share it with your friends, and also make sure to do subscribe to the channel. Let me know your feedback in the comments. Bye.